Hello, everybody. Once again, my name is Brad Tallis with Next Gen Solutions. I wanted to welcome all of you to this sheet metal webinar. I'm going to be going through and showing some tips and tricks on how you can use the sheet metal functionality inside of Fusion. So if you have any questions, please feel free to post them out into the Q&A. If one of you doesn't mind giving like a thumbs up, making sure you can see my screen okay and you can hear me okay, that way I know everything is working correctly. So I'm running this one by myself. I usually have somebody else helping me. So just want to make sure you guys can see my Fusion screen. Looks like somebody responded. Okay, thank you very much. I appreciate that. Okay, let's dive right in. So I'm going to be talking about the sheet metal functionality, and I have some tips and tricks that I think will help you all use sheet metal a little bit easier, a little bit more powerful. And I'm actually going to start out kind of with the basics, but there's some options in there that not a lot of people understand and what they do and what they're for. And I have I think a really kind of a good example of what it does. And then we'll kind of go through and show a couple different methods. So I'm in Fusion, I'm in my design workspace. Typically you're in the solid tab, but you'll notice, we have surfacing, meshing, etc. And then we also have sheet metal. So I'm going to click on the sheet metal tab. And this puts me into kind of like a sub workspace, basically, with just the sheet metal command. So you'll see things such as flange and bend and convert to sheet metal, etc. But the first thing I'm actually going to talk about is the sheet metal rules. So under the modify menu, there's sheet metal rules, and this brings up the sheet metal rules. Now, default Fusion has basically 6 of them. So steel, stainless steel, aluminum in millimeters, and then steel, stainless steel, aluminum in inch. But then you'll notice I have some other ones in here, and you can create your own custom materials or rules, I should say, in here. So for example, I'm going to just hover over stainless steel inch, and you'll notice I can expand this open. So I'm just going to click on that, and it tells me what the thickness is, what the K factor, miter, rip, seam, gap, etc. Okay. If right next to it, you'll notice there's an edit rule, and then there's a new rule. So I'm going to go ahead and click on new rule, and it's basically going to copy all of the settings from this existing stainless steel inch rule. So this is kind of a great way, like if your shop, you always use like rips instead of rounds, if you use very specific settings for like your bend reliefs and your corner reliefs, etc., you can create one of those. And then let's say you do 10 gauge, 12 gauge, 14 gauge, etc. You could just copy that. You basically just, say new rule on the existing one, and it's going to keep all of your settings that you had set up on the previous one. So it's a quick way to create a lot of materials. So I'm just basically copying stainless steel inch. I'm going to call this stainless steel 0.123. Okay. And I'm going to make the thickness 123, just so it's something, kind of visible to see. K factor, I'm going to leave that default, but this is basically when you bend something, part of the material is getting compressed and part of the material is getting stretched. And then there's a point where it's doing neither, right? It's kind of sort of in the middle of that material, and it's typically around 44% of the thickness for that K factor. Different materials will have different K factors. You can find these online. So for example, if you're bending Lexan or plexiglass or whatever, that might have a different K factor than metal would, for example. Okay, this one we're going to come back to because this is probably the #1 question I get with sheet metal is how do I change the gap? And you can see right here, it's basically saying the miter gap, the rip gap, and the seam gap, they're all set to whatever thickness is, and that is 0.123. So we're going to see that as we go through, and we're going to make a change to that later on. If I expand upon my bend conditions, you can see my default bend radius is whatever thickness is. So maybe you're using sheet metal to design things out of cardboard, and that kind of like kinks a little bit more than bends like metal would. So you could change your bend radius to be smaller than what the thickness is, like 0.05, for example. So you have the ability to specify the default bend radius. You can see here's what I was talking about earlier, the relief shapes, round, straight, tear. And then we'll talk about the width, depth, and remnants here in a little bit as we go through. But you can see they're all referencing whatever thickness is. So in this example, my relief depth is whatever thickness is times 0.5. So it's actually going to be half of 0.123. My relief remnant is going to be twice 0.123, right? Okay, and then lastly in here, we have corner conditions. So for example, if you're bending two flanges together like this, it'll have a corner, and we're saying we want to do a round relief shape, square, tear. There's a bunch of different ones. I use arc weld and tear quite a bit, but you'll see those as we go through. We're gonna change some of the rules, all that kind of stuff. Okay, and then the same thing with like the 3-bend intersection. You have a couple different options here. Full round, round with radius, intersection, no replacement. And what I'm going to recommend we do is I'm going to show this in a demo. You can override these rules and pick different ones and see what they do. So, okay, so long story short, I just basically copied an existing material, gave it a name, gave it my thickness, and I'm just going to leave everything alone. I'm going to go ahead and hit save, and you'll now see a new material in here called stainless steel 0.123, and there's the thickness. Okay, so that's how you create materials. The next thing I want to talk about are the flange options when we create a flange. So I'm going to go into this cube example here. This is a cube that is, it's 3 inches wide by 4 inches long. Okay, and you can kind of see that here, by 2 inches tall. So it's a 4 by 3 by 2. And that'll come into play here in just a little bit. Okay. So I'm going to go into my sheet metal tab, and the very first thing you need to do is you have to create a new component. You always want to use components for sheet metal. They have to be. So you'll notice when I say new component, I actually get this dialog that says sheet metal. By default, it's usually set to standard. This is kind of what you usually see when you create a new component, but here it's now sheet metal. And I can give it a name if I want to. I'll just leave it alone. But then notice the sheet metal rule option. Okay. And if I click on that, I'm going to see all of my rules. So let's use the new one that I created, this stainless steel 0.123. I'll say OK. And I now have a component in here called stainless steel 0.123. I'll go ahead and create a sketch on this top face, and I'm just going to use that top face, and I'll use the flange command. Now the flange command is multiple commands in one. In fact, I think if I come in here, we just kind of hover over it, you'll see the description. So creates a sheet metal base flange, a contour flange, an edge flange, or a lofted flange, depending on which profiles you select. Okay, so it's one of those commands that has quite a few options in it. So I'm going to say flange, and I'm just going to pick on that sketch that I created, that rectangle, and you'll notice it automatically extruded it to the correct thickness. So this thickness is 0.123. A couple quick options in here. Orientation, I can say side 1. If I say side 2, it's going to basically extrude down instead of up. And if I were to say center, you could see how it's basically like a symmetrical extrude. But in this case, I'm just going to say side one. Okay. So then I'm going to go ahead and click on an edge. I could come up to the flange command to run it from there, or I could just right mouse click, and you can see it's in my my mouse click right here. So I can go ahead and do the flange here, and I'll start to drag. Now you'll notice nothing is really happening when I'm starting to drag until I get a certain distance, and then it's doing the rules. So it's creating that bend radius for me, and I'm basically specifying a height, and it's bending it at 90 degrees. Okay, so let's talk about this menu for a little bit. So first of all, the type, you'll notice it says edge flange and then lofted flange. This is somewhat new, the lofted flange. I'm going to give a quick demo of that here in a moment. But we're going to do what's called an edge flange. And then you can see it says edge one and it says full edge. Well, if I hover over, and this is one of those things that I don't think a lot of people know about, if I hover over this, I get a little pull down, and you can see we have different types of edges. So full edge is going to go the full length. If I say symmetric, I now get these arrows. And if I drag these arrows, you can kind of see how it's basically selecting that edge, but then we're specifying a distance. So in this case here, I'll just say 0.5, oops, 0.5. So it's going symmetrically 0.5 to here and 0.5 to here. So this tab is 1 inch wide. And it will always be in the center of this edge. Okay. The other option is two sides. And you'll notice I now have two distances. So here I could come in and you'll notice it's measuring from the center. So I'm saying from the center, let's go over 1 inch that direction. And then from the center, let's go over, 1.5 or something like that in the other direction. Okay. And you can kind of see the little arrowhead here specifying, 1.5 from the center and then 1 from the center to the other side. So that's the two side option. Then we also have two offsets. And you'll notice this time it says reference. So I'm going to start dragging so you can kind of see what's going on here. And it's referencing this endpoint right here. And I can say, I want this tab to start, 1 inch from the edge, let's just say. Okay. And then this other offset, let's do that maybe 2 inches from the edge. So you can put this tab wherever you want. So I'm not specifying the width. I'm not specifying the width of the tab. I'm basically specifying where I want the tab to be. Okay. So those are the options. So full edge, move that out of the way. So full edge, symmetric, two sides, and two offsets. So I'm going to jump back to this full edge. And let me move that. So the other thing you'll notice is the plus and the X. So I could add in more edges. So if I go ahead and select that other edge, you'll see that it now has two different edges. And because I did that, I'm getting my round relief. This is that corner relief, which we'll talk about here in just a moment. If I add in these other two edges, you'll see all four of them happen at the same time. And I have the ability to change any of these. So I can make this last one a symmetric, and make it look like this instead. Okay. And then you can also remove any of these out of here just by hitting the X on those. Okay. So then we have height, and I'm actually going to flip the faces, and I'm going to use this cube as an example so you can kind of see a couple things happening here. So we remember this was a 4 by 3 by 2. So I'm going to set my height to be 2 inches. And notice the result that I get. Okay. And that is this height datum option. And it says outer faces. So what that basically means is it's measuring from up here 2 inches down to right here. So that is why it looks like it's about the thickness of the material short. So if I change outer faces to inner faces, notice the result that I get. So now it's basically measuring this inside face to here is 2 inches. And that's basically what I want in this example. So you can change your height datum from outer faces to inner faces. And again, depending on what your expectation is, what your end result is that you want, you might want to change the height datums. Now, the last one in here is tangent to bend. We're going to show that here in a little bit. Not in this example here. I'll show it in a different example. Okay, hopefully you can kind of see the cube. You'll notice that the sheet metal is basically folding inside of this cube. And that is this bend position option. And you'll notice it says inside, and that's kind of makes sense. That's what we're seeing. If I change it to outside, you can now see that the bend is happening onto the outside of the cube. So here's inside, here's outside. If I change it to adjacent, now the bend is basically happening right at the edge of this cube. So let me go back to outside. You can kind of see where the tangent line is, and then it's bending. So this wall is touching the outside of the cube, but adjacent starts where the bend starts at the outside of the cube. So it's kind of a really visual way to see what these options are. And again, I just created the cube, and then I just created the flange on the top and just played around with the different options here so you can kind of visually see what results you get. So for example, if I were to add in this edge here, I'll go ahead and flip those. So let me go ahead and do both of these at the same time. Let's go flange. I'll say that edge and that edge. Start to drag. I'll set my height to be 2 inches. So I'll go 2. And we can see the bend positions on the inside. I'll set it to the outside, and we can kind of see what that looks like now. Okay. And I want my height datum to be inner faces. So that box or that cube will sit perfectly inside of this enclosure. So those are those options. Okay. You saw me do this earlier. I selected basically this bottom edge here and this bottom edge here. I can flip those edges if I need to. So if I accidentally pick the wrong edge, I can flip them around. Miter corners, let me go ahead and show that option. So I'll go ahead and turn off the cube for now, and I'm just going to say flange, and I'll select these 2 edges here and start to drag. And you'll notice that it automatically miters that corner for me. That's this option right here. If I turn that off, you'll notice I get a weird result, and I got a warning basically saying, let me do that again. The flange is intersecting the body. This will probably result in the body being unable to unfold or flatten. And sure enough, you couldn't manufacture it like this. So miter corners creates that automatic miter for you. So check out how fast you can basically, create an enclosure here. So I'm going to do all 4 of those edges. Then I'll go ahead and select all 4 of these edges. Right mouse click, flange, start to drag. And it has, that miter corner for me. I can specify my height. Let's just say 0.5. say okay, and I now have a sheet metal box, like a outlet box or something like that. And think about how long it would take you to model this normally without using sheet metal, for example. Okay, I'm gonna leave this model up. We're gonna come back and change the gap and all that kind of stuff here in a little bit. Oh, actually, I need to come back. Sorry, I lied. Let's go back here. I want to continue down this menu. So we just talked about miter corners. I'm going to talk about override rules. And I actually use this one fairly often. Let me move this on the screen just in case. So I activated override rules, and then you can see it's broken down into those four main things, those rules that we saw when we were creating the material. So I'm going to start by doing a bend override, and you'll notice that the radius is the thickness of the material, 0.123. So I could, for example, come in here and say, let's make that 0.25, and you'll see how it updated accordingly, okay? Or I could change it to something smaller like 0.025, and we get a much smaller bend radius. So again, you can come in and specify what you want that to be by default, but then you have the ability to come in and override that. For right now, it's doing all four of them, but I could do it for each individual one, for specific flanges, etc. Okay. Then we have bend relief override. And you'll notice it says relief shape is round. So I'm going to come in here and say straight. And I need to actually, sorry, have a bend on here. So I'm just going to do it on like this guy here. I'll say create a flange. Instead of a full edge, I'll just do a symmetric and just drag it so we have something like this. I'm not going to worry about dimensions. So this is a bend relief right here. So we're bending that over. It has to have a little bit of relief so it doesn't damage the material. And this is a corner relief. So that's the difference there. So let's take a look at this. I'll say override rules, bend relief. So you can see it says round. I'll change that to straight. And now you can see how it looks like a straight bend relief. I could set it to tear, and there's literally no relief. It's just like a slight, cut there, and then you're bending it over. So that's the tear. I'll go back to the round, and then you'll notice the relief width, ironically, is what the thickness of the material is. So I could come in here and say, I want that to be divided by 2. And you can see I get a quick update of, it's basically half the thickness of the material now. Or I could say I want that to be 0.02, and I get, even a smaller result. So I can come in and override particular edges, flanges, etc. Okay. Then we also have this relief depth. So I'm going to set that back to 0.123. We have this relief depth, and it is, hopefully remember it said thickness times 0.05. So this is half of the thickness. I could come in here and say, make that 0.1, and you'll see how that depth went a little bit deeper. In fact, let's do 0.3 so you can kind of see what that looks like, over exaggerating there. Okay. I'll just do 0.0625 in this case. And then relief remnant, what this is, let me change to 2 sides. So actually, let me do full edge first. Okay. Then I'm going to change it to 2 sides. I guess it already had the number. So this right here is my remnant. If I keep dragging, you'll notice it jumps off. It basically goes away if I'm really close to the edge. And this is basically because if you were to like punch or stamp this sheet metal out, something really small like that might get bent. It might be hard to, plasma cut or laser cut, whatever it might be. So this distance is what this relief remnant is. So if I made this much smaller, 0.02, and I drag to the left, you'll notice it stays there much longer until I get within 0.02, and then it finally disappears. So you can specify what the relief remnant is also. So you can override those. And this hopefully is also showing you the settings when you create the rule. We talked about the shape, the width, the depth, and the remnant. This is now you can visually see what each of those does. Okay, the two bend corner override. So let me go into here and kind of take a look at the corner here. Override the rules, two bend corner override, and you'll notice again it says round. Well, I'm going to change it to square, and now we get kind of like a square relief. I'll do a tear, so you get something that looks like this. Trim to bend, again, a couple different options. Now I'll use trim to bend every once in a while if I want to, for example, pull this face to be in line with this face over here. So I'll use trim to bend every so often for that. And then we have, excuse me, linear weld. And then we have arc weld. And I like arc weld. I use this one quite a bit. Okay, so how do we change this gap? You can't really override it very easily here, so I actually changed the material itself. Okay, so let's go ahead and I'll cancel this out of here. And we're using the stainless steel rule of 0.123. Okay. In fact, I'm gonna really quickly create another flange like so. So we have some miters going on. Let's just do something like this, 0.8. Okay. So I'm gonna not switch the rule, but I want to see what rule this is. This is 0.123. So I'm gonna come in here and you'll notice it says in this design. And so I have this stainless steel 0.123. I'm gonna go ahead and edit the rule. And let's move this out so you can kind of see what's going on here. So miter rip seam gap is set to whatever thickness is, 0.123. So I'm going to come in here and say, I want it pretty tight. Let's just do thickness divided by 4 and watch the result that I get. These are now much closer together. Here's my corner reliefs, all that kind of stuff. They're much closer together. So if you need to close the gap, so your miter gap, your rip gap, or your seam gap, that is this right here. So I could come in and type in some number, right? So I could come in here and say 0.05, and then you'll see that update. So now it's set to 0.05. Or I could, make it extremely small. So say 0.005. And now you can see how close together that is. And then I don't like the round reliefs here, so I might come in here and say, you know what, for my corner conditions, instead of round, I want to use arc welds. So I'm going to hit save, and it's going to update that rule, and now I'm using arc welds, and I get a much cleaner, nicer looking object, sheet metal part, that would be easy to weld, for example. So hopefully that makes sense and you learn something new with this. The other thing I could have done is, and I've done this before, where I'll have a material and then I'll just copy that material and change, is it an arc weld? Is it a round relief? Is it a square relief? So depending on how it's going to get manufactured, my material is all the same, but it's just the different options that I'm changing in there. So instead of coming in and editing the material, I could come in here and switch the material. So you can see right here, switch rule. So I'm going to click on that. Right now it says it's stainless steel 0.123. I could come in here and say, okay, I want that to be 12 gauge steel. I'll say okay, and you can see how it changed to whatever the settings for 12 gauge steel is. If I switch that back to 1, 2, 3, you'll notice the round will become, oops, or did it not do it? Or do I have more than one? So I do, sorry, I have more than one. So then it switched it back to that. So a couple different options. Okay, let me check. So let me see, Q&A. Okay, no questions so far? Okay, good. Let's move on. So you also have the ability to create flanges using open profiles. So let me show you what I mean by that. So I'm going to come in here and create a shape. I'm just going to do something like this at an angle, maybe down and over. So I'm not doing any fillets or anything like that. I'm basically drawing like a side profile. And then when I say flange, I can click on that profile and start to drag. And you'll notice that it's doing the bend reliefs for me. And once again, I can kind of control which side does it bend on. So this is a great way to create, complex kind of shapes instead of starting with, a rectangle and then adding a flange of another rectangle, or, adding a flange on an edge and then adding another flange on an edge, or adding another flange on an edge. I'm basically starting with a side profile. And then I can come in and say, you know what, I want flanges on these two edges. And it will create those bend reliefs for me automatically. In fact, I'll go ahead and select, let's do this. I'll do all 4 of these. And I get this result. Now notice it mitered these corners for me automatically. Everything looks good. Now here is a tip that I use a lot in Fusion sheet metal. So I just designed this part. The next thing I'm going to do is I'm going to say unfold. Okay, now it's asking for a stationary entity. So basically you want to click like a flat face. So on this box, I would either click the inside or the outside flat face. And then I could say unfold all bends. And if it lays out flat, we know it's manufacturable. We know that there's no overlapping geometry and all that kind of stuff. And you can see like what the arc weld looks like. It's kind of cool. Okay. So what about this guy? So stationary entity, I'm going to click here. That unfolds, except I get a, oh, I must have not picked that back edge. I was like, why is there missing edge? So this is manufacturable. And I verified that by just doing and let me go ahead and fix that. Make sure I grab that edge there. There we go. So I'll come in and say unfold, click on a flat face, unfold all bends. And because it unfolded, I know that that piece is manufacturable. So, okay. I'm just checking my notes really quick here. Okay. So also related to this, kind of that profile, I can come in here and create a sketch like this. And I'm going to rotate it isometrically so you can kind of see what's happening here. And I'm just going to draw a line like so, like this, for example. Okay. And then I'll say flange. So what are the edges? I'll go ahead and select this. But if I start to drag, it's just going to kind of be floating out in space. So instead, what you do is you click this edge and you click that edge, and it joins this profile to that other sheet metal tab. Okay, pretty cool. Let me do that again. So I just have a profile touching that edge right there. I'll select that guy, and then I'll select that one, and it joins it to it. It does the exact same thickness of that edge, or length, I should say, of that edge. And we now have something that looks like this. Is that manufacturable? I'll come in, I'll just say unfold all bends. Yes, it is, right? So another neat little tip with the using profiles for the flanges. And then the last one, I'll go ahead and create a new design here, is the lofted flange. So we're going to do stainless steel 0.123. So under the flange command, we've been doing edge flanges. So the next one is lofted flange. And to do that, you have to have two shapes. So I'm going to quickly just create, I'll do a rectangle. Let's just do something like this. And I'll say 8x4. Finish my sketch. And then I'll do an offset plane a certain distance up. Let's just go maybe 6 inches up. And I'll create a sketch on here. And let's do I'll just keep it simple. Let's just do a circle. That's 3. Okay. So under sheet metal, I can say flange, and I want to do a lofted flange. So it's asking, what are the profiles? So I'm going to select those two profiles and notice what it's doing. It's actually pretty amazing. So it's going from this circular shape to this rectangular shape, and it's creating all of these bends for me. So in this menu, you'll notice we have forming type. We have what's called a break form or a roll or die form. So if I do that, I get something that looks like this. So it's not faceted anymore. I'm going to go back to the break form. And then you can see we have these facets. So I can do chord tolerance, facet angle, facet distance, or facet number. So right now we're doing chord tolerance. Let's change to facet angle, and I could say I want a facet every 10 degrees. And so I get something like that. Or I want a facet every 20 degrees. I'm going to get a result that looks like this. Same thing with facet distance. You can specify the distance that you want. So let's just say 0.3. I get that. Or I could do the facet number. So we're basically saying we want 6 facets on each of these sides. Okay. If I say okay, you'll see I get this result. Now, can I unfold this? And the answer is no, because there's no opening or whatever. I would have to rip an opening in here, and under modify, you'll notice we have this rip command. So I'm going to go ahead and say rip. It's asking for a face or an edge or a vertex. You'll notice it's red as I drag along here, but if I get near the center, it kind of snaps and turns green. So I'm going to click there, and then I'm just going to go ahead and click that point there, and I can specify what the gap width is. Let's just say 0.1. I'll say okay, and let's see if we can unfold this. So what's my stationary entity? I'm going to click on that flat face, unfold all bends, and we now get this result. So yes, now it's manufacturable. Okay. Okay, I'm not going to save that. Let's go here. So the next thing I want to talk about is hems. And I did a quick Fusion Friday about this a little while ago. I don't know if any of you have seen that, so I'm going to go cover it here. We don't have an automatic hem command or a safety edge command or something like that. So I'll show you a quick tip on how to do this. So I'm going to go into my sheet metal. I'll just create, we'll use that 0.123 again. And I'm just going to start with a rectangular shape like so. Create a flange, we get this. Okay. If I were to click on this edge and start to drag, I get my 90-degree height, or my 90-degree let's just say 1-inch high flange. Now watch what happens when I start to rotate this. We haven't talked about changing the angle. So by default, it's set to 90, but as I start to drag this, it kind of folds over on itself, but you'll notice the height is getting smaller, and even my shape is changing size. And that is not what I want in this example. Okay. Well, here's where those other options I said we'd get to later. So I'm going to say tangent to bend. So my height of 1 is now from the top here, tangent to this bend. So watch what happens when I start to rotate. You'll see that that height now stays the correct height, or length in this case. But when I roll that bend over, it still keeps moving. Well, let's change the bend position. Instead of inside, outside, or adjacent, I'm going to say tangent. And now when I rotate, you can see that that tangent is staying put. So I can now roll this over. But watch what happens when I get to 180. I get kind of a weird result. It just mathematically can't calculate that. So my trick here is set it to like 179.99 or something really, really close. Okay. However, this gap is way too big. I want it to be like we folded it over and kind of, pressed down on it. So I'm going to come into my override rules and I want to override my bend. So instead of 0.123, I might just come in here and say 0.002 or something. Let me do, it might be too small. Let's type in 0.0. What's going on? Give me a second here. Okay. Let me start that over. I might have clicked wrong. Give me a second. Flange. Rotate it to 179. Tangent and tangent. Okay. I'll do my height and override my bend. So let's just say 0.0123. There we go. And so you can kind of see how now it's a very small bend radius, and we basically kind of like folded over that edge. And if I were to do that on all 4 of these edges, we'll get kind of a cool result, because it's going to do that miter for me also. And we basically like hemmed all 4 of those edges. Let's do 0.5 for the height or something. So that is a quick tip on creating the a hem. And what's nice about this is, and I don't know if you noticed me do this, but one of the tips I shared in the Fusion Friday is you'll see these 3 little dots. If I click on those, it actually remembers my last settings or entries that I put into these dialogues. So for example, under the angle, I clicked on that, and there's that 179.9, and here's that 179.99, whatever. Here's 45, right? So it remembers what you had that set to, and you can come in here and very quickly pick those numbers instead of having to type them in. So, okay, hopefully you're all learning something new. So the next thing I wanted to talk about is creating bends. So in sheet metal, we actually have a bend command. So we've been using the flange command, but let's say I'm designing, I bring in something that already exists, like a sketch of a flat profile, and I want to bend that together. So that's the example I'm going to do here. I'm going to bring in, I'm going to start by creating a new component. Let's just stick with the 0.123. And then I'm going to insert in a DXF. And let's just do maybe this top face here. I'll select that DXF. And here is a couple cool things. So this came in from a different tool, whether it was SolidWorks, whether it was GrabCAD, whether it was, AutoCAD or something like that. But you'll notice it has DXF layers, and we can see we've got this outer profile. I can turn that on or off. We've got these inner profiles. I can turn them on or off. And then we have the bend, and you'll notice like the middle line is turning off. And then we have the bend extents. So that's basically the tangent edge of the bend. So I don't need those. What I do care about is the profile, and I care about where the bend is. So I'm going to turn off bend extent and say, okay. And I now have a sketch, basically. Well, I want to turn this into a sheet metal part. So I'm going to come in here and say flange, and I have to select these profiles. So I'm just going to quickly select those guys. And it's going to be using the rule that we specified, 0.123. And I'll say, okay. And I now have this flat sheet metal part. But I want to start, adding in the bend. So I'm going to turn my sketch back on and use the bend command. So I'll say bend. Now it's asking for a stationary side. So I'm just going to click over here. I'm basically going to start from the outside and work my way in. So I'm going to click here, and then you'll notice as I get near, let me do, give me a second, give it more time. Create bend, stationary side. Let me do that. And of course, now it's not doing it. Let me try. Wow. Basically, it highlights blue, and I'm not sure why it's like a dark blue. I'm not sure why it's not doing it for me now. Give me another second, and I might have to create bend. Let me do face. Wow. Okay. I apologize, guys. I did this in the practice, and it worked perfectly. So I do not know why it is not doing it. So I basically click on that bend, and it would bend it for me. So let me see if I can create a new sketch. Let me just do this really quick, just to kind of show you the idea of what it does. Finish sketch. And it might be because I'm rushing, because I just looked at my time and time is running out. Yeah, so there we go. Must be something to do with my sketch. I'm not sure exactly what. So it's asking for a stationary side, and then I can come in here and I click on that, and you can see that it's going to bend using that line. Okay, and I was hoping to show with the sketch, and the other thing is you can flip the direction of the bend, and then the important thing is this bend line position. So you'll notice we got rid of the tangency edges, and we just kept where the bend is. So instead of start, I want to say center. And so this is basically bending where that bend line was. So I can specify center or end or whatever. I have control over that. Okay. And then you can, if you had to, you could turn bend reliefs on or off if you need to. So I'll say, okay. Again, not sure why that didn't work, but let's do this. And I'll just draw another quick line. I'm just going to pick here, and I'll just do something up here for now, just so you can kind of see what you can do here. So I'll do the exact same thing. I'll say create bend. I'll say stationary side. Then I want this side to bend, and I want that to go the opposite direction. And I'll say center on that one. And then I could come in here and say bend. So you basically work your way around. So I want to bend here, and you can kind of see the result that we would get. And I would keep going, and basically I create this part from an existing sketch. So you don't have to always just start with, redraw or whatever. I could bring in AutoCAD drawing. It could be something off of a web page or whatever, and use that to create a sheet metal component. So, okay. Let me just check my notes here real quick. So kind of taking this to the next level is converting parts into sheet metal. And so this is something I downloaded off of GrabCAD, and you'll notice that it is not a sheet metal component. If I come in here, you don't see like unfold or anything like that. The only command you see is convert to sheet metal. And it comes up and it says, hey, before you do this, you must switch to the parametric modeling mode. You'll notice I have no timeline. That's because I just opened this step file or whatever it was from GrabCAD. So I'm going to say capture design history. And now it says convert to sheet metal. What's the source? I'm just going to click on a face and it tries to detect what the thickness is. In this case, it found that it was 0.105 thick. I could specify a particular sheet metal rule, and then you'll see it says note the thickness will be changed to 0.105. So I'm just going to go ahead and say okay. And I now have a sheet metal like icon right here. And if I come in and say unfold, let me just click on a stationary entity, and sure enough, Fusion is able to unfold that. And this blows me away. The fact that, I didn't even have to create this thing. I was able to find it. I want to make one of these shelves. I can unfold it, cut it out on my laser cutter, plasma, whatever, water jet, and then, fold it together and create the part. So, so here's another example. Let me just, here is that finished part. Again, you'll notice it is not a sheet metal component. I'll come in here and say create, capture design history. I'll just click a flat face. This time it recognized this as thickness of 5 millimeters. And then you'll notice there's an option here that says show matching rules. And I have a sheet metal rule called steel 5 millimeters. So it's going to use that one. So it's going to use the rules that I have in this particular rule. So I'll say okay. And if I come in here and unfold this, it lays it out flat. So we know that that is a manufacturable sheet metal component. So the trick with this, I shouldn't say the trick, the requirement for this is it has to have equal wall thickness. So when you bring this model in, it has to have been created in a good manner. And what I mean by that, for example, is if I were to, I don't know if it's going to let me do this or not. Yeah, if I were going to do some, if I had something like this where it's no longer equal wall thickness, this wouldn't convert. It would error out. So you do have to make sure that it has equal wall thickness. Also, if the I don't know, let me do this. If it came in looking like this, you're not going to be able to unfold that, right? There's no bend radius or anything for it to bend along. So you would have to come in and measure what this thickness is. It's 5 millimeters, so I'd have to come in here, make this a 5 millimeter fillet, and then make this like a 10 millimeter fillet or whatever. So you might have to do some work to convert a poorly drawn 3D model into sheet metal. But in this case, this one was probably created in another tool with their sheet metal tools, whether it was Inventor or Pro E or whatever. It came out very nice, equal wall thickness. So then Fusion was able to convert it. So, okay, this next one. I get this question a lot. What's the difference between unfold and flat pattern? They both do pretty much the same thing. Let me show you what I mean by that. So I have this weird example. So I've got this sheet metal part, and then it's got a tab that actually goes down through the material, and there is a gap. So you can kind of see there's a gap all the way around this tab. So you can kind of think of this like a cardboard box or whatever, where they push a tab down into a hole or a slot to try and keep it assembled together. That's kind of what this is representing. So I'm going to come in and say unfold. It's asking for a stationary face, and it lays it out flat. I'll say okay. And you'll notice it says refold faces. So what's neat about this is I can actually, model, I could draw a slot on here, punch it through, and then refold. In fact, I'll go ahead and do that just because how powerful this really is. So let me do a quick slot, center to center. I'm just going to do, and again, not worrying about dimensions or anything, just to speed things up here. So I'll say extrude. So I'm modeling this in in its flattened state, and then I'm going to say refold faces, and you'll see that it actually refolded the faces with that slot feature. Pretty neat. Okay, so if I come in here and I say create flat pattern, it's asking for a stationary face. I'll click on this, say okay, and I get pretty much the exact same result. Right? It lays it out flat. I can see where my bend lines are, where my tangency lines are, but you'll notice I'm in kind of like, sorry, my dog's barking. In this environment where I'm in a flat pattern environment. And what it's neat about this is the flat pattern allows you to modify how the part is going to get manufactured. Okay, so let me show you what I mean by that. If I punch a hole through here, let me just do something like this, finish my sketch, extrude this guy. I'll just say go all the way through. Okay, so that's in my flat pattern. Watch what happens when I finish my flat pattern. You don't see that hole. Okay, I go into my flat pattern, you see that hole. So you can actually change how the part is going to get manufactured. And in this case, the reason I use this example is let's pretend this is made out of cardboard. I want this tab to go into this slot and get kind of compressed. So I actually want this slot to be smaller. So I'm going to come in here and select these two faces. I'm just going to change, and I'm going to over exaggerate so you can really see what's going on here. I'll say, okay, finish my flat pattern. Here's my design. Now, if I had tried to model this in sheet metal with that hole being smaller, it would say, hey, I self-intersect. I can't do that. It won't unfold. So here's by design, and here is by manufacture. And I hope that makes sense. It's actually really, really handy for making some design changes that you don't want to affect your actual 3D model, but you need to have affected for manufacturing. Here's another example of that. So I used sheet metal to create this cardboard box. Okay, and if I come in here and unfold, so I'll just pick this as my stationary entity. You can see that there's that box laid out totally flat. I do have these little tabs right here that go into these little slots. Okay, now if I put it back together and we zoom up on this, you'll see that those slots, or I'm sorry, those tabs are smaller than the slot. However, when it's manufactured, those tabs will be a little bit wider, so they kind of get compressed when they go into the slots. Now, you might be looking at this and saying, well, how did you do that? That looks really complicated. I mean, we've got like all these bends and folds and stuff like that that are kind of holding this whole thing together. I'm just going to step through this really fast just to kind of show you, I started with the base, added the two sides, and then folded, basically kind of like added some flanges like so, and then there's where I created the holes, and that's where I created the tabs. And I actually used the flange command to add those little extra tabs, but they're at 180 degrees instead of 90 degrees. And then you'll notice I just mirrored all of this from one side to the other. So I only did one side. Then I worked on the front, and you can kind of see, created those, and then I create flanges on those sides, kind of roll in, do the same thing on the back. Then I'll unfold it every so often to make sure it can unfold. Is it manufacturable? Then I fold it back together. And I'm just going to kind of jump through here. So then I create the top that kind of rolls over the front here. And it's all by using, I'll come in here and you'll see interfaces, or this time I said adjacent. So I wanted to start the bend at the edge. So for example, okay. And then it's just basically adding flanges. And once again, I mirrored, you'll see. So here I unfolded it, made it change to it, like added a big fillet, folded it back together, mirrored that from one side to the other, mirrored that from one side to the other, et cetera, et cetera. So it's literally just creating flanges, laying it out flat. Here I come in and modify those tabs, add some chamfers and some fillets to them, and then we're done. So that's how I did that. But okay. Actually, I'm going to jump back here. So using the mirror command, this is actually pretty cool. I wanted to show this. So I created this shape right here. Check this out. I'm in the sheet metal tab. I'm going to go back to solid. I know we're going to run a minute or two over. I apologize. I'm going to say create mirror. I want to mirror that. What's my mirror plane? I'll say right here. And I want to join that together. And you'll notice this is now one solid piece, but is it still a sheet metal component? Can I unfold it? Well, let's try this. I'm going to say unfold. I'll click on that. And sure enough, and this kind of blows me away. In other CAD systems, I wouldn't be able to do that. I'm going to go ahead and say mirror. I want to mirror that body along this face here. I'll say okay. I'll do that one more time. Mirror, just to kind of show how powerful this is. I'll mirror that. So I'm creating some kind of a, bracket that holds wires or whatever. I'll come back into sheet metal, unfold, voila. It actually is still a sheet metal component. So, okay. I know that was like drinking from the fire hose. I just wanted to share a couple of those tips. One of them being like how to change the miter gap, the corner gap, all that kind of stuff. Hopefully that made sense to you. The cube example kind of really showed how, what the options are, inside, outside, tangent, all that kind of stuff. So I thought that was really important. I showed how to quickly create hems. The bend example didn't go as smoothly as I wanted for whatever reason, but you can bring in flat drawings and create sheet metal parts. You can bring in existing sheet metal parts from other systems, convert them and use them inside of Fusion, like we did with these guys. And then showing you how you can use the flat pattern to change the manufacturability. So let me check to see if there's any questions. It looks like there are. Yeah, so I think, Jeff, I think you called it out correctly. You said, don't you need to do it on the sketch side? I probably was rushing and my sketch was on the other side or whatever. You're probably correct on the creating bends. I mean, to me, it looks like my sketch is on the top, but I'm not, something was different and it worked when I practiced. And of course it doesn't work it in the demo. So Matt asked, can you specify, a bend deduction allowance versus K factor? No. So basically the K factor is, defining, and again, I'll use this example here. This part here is being compressed. This part here is being stretched. And so about 44% in is kind of where they're both equal or zero out or whatever. So you can't change the K factor per bend or whatever. You would just come in and basically override the rule for the bend radius or whatever. So Robert asked, is this webinar recorded? Yes, because you guys attended, you'll get a recording sent to you. I'm not sure how long it takes for that to process, but you should get a follow-up email. Oh, and then somebody asked, are all of these tools available in the basic Fusion? Yes, I did not use any tools like extensions or anything like that. This is all base product. So yeah, thanks for asking that. With that, let me check the chats really quick. No more chats. I want to thank everybody for attending. Hopefully you found this useful, and I look forward to seeing you on our next webinar. So keep an eye out for that and have a wonderful rest of your day. Thanks.